Alright, look at this number 1 here. We got 4 sine x equals 2 sine x plus square root of 2. And these 3 I chose today are the 3 that are very similar to what's on your exam. So on number 1 right here, our goal is to get 1 what? Sine x, isn't it? We have 4 sine x here. We have 2 sine x here. We just want 1 trig function in the problem, don't we? So how can we get to that, Colin? Not quite yet. We got 2 of these. Are these like terms, guys? So could you combine them? So I need to move the what over? 2 sine x. That gives me 2 sine x equals square root of 2. Now, how do I finish getting sine by itself? Divide by what? 2. Very good. So sine x equals square root of 2 over 2. Okay, so I got to think on the unit circle. My sine is my y value. What reference angle family does this belong to? Pi over 4. The sine is positive. Where's your sine positive in the coordinate plane? Quad 1 and quad what? 2. So what are your answers there? Pi over 4 and? Very good. That is your answers for that problem. Okay. Now, number 2. I have 2 different trig functions going on. I got something that says cosine sine and something that says cosine. Can I combine those at the moment? No. What would you do, though? Get them on what? The same side and then do what with it? Factor something out. Remember that strategy. So I'm going to bring that over. Cosine x sine x minus 3 cosine x equals 0. Now I can factor out a cosine x. Now set them both equal to 0. Move this over. Is there anywhere on the unit circle that we have a sine value of 3? So don't have to worry about that? No. Cosine x equals 0. Where does cosine equal 0 at? Very good, and? Very good. Are there any questions on that one? Okay. Now let's look at this one. Now this one's a little bit more complicated. What do you notice in front of this theta right here? A number. In front of these x's, it was just understood 1, didn't it? You remember how these were kind of a more difficult equation? You might want to make sure you jot this one down. Okay? Jot this one down. First thing you're going to do is just like normal. You're going to get your cosine by itself. I'm going to divide both sides by square root of 2. Okay, thank you. I'm going to divide both sides by square root of 2 and get the cosine by itself. Cosine of 2 theta equals 1 over square root of 2. Well, you know when you rationalize that, it gives you square root of 2 over 2. Now, you're going to ignore this for just a minute. Where does your cosine give you square root of 2 over 2 at? What 2 values? Pi over 4 and? Not 3 pi. 3 pi over 4 will give you negative, wouldn't it? 7 pi over 4. And you remember you used to put 2 pi in? Because you got that 2 theta there? Now, how do I get rid of this 2? I'm going to divide everything by what? 2. When I divide by 2 here, guys, is that going to affect the numerator or denominator here? Pi over 4 divided by 2. It's going to affect the what? So that's going to be pi over 8, isn't it? Plus pi n, because these 2's cancel out. Theta equals, that would be 7 pi over 8. And remember, then we would say let n be 0, let n be 1, and we would pick the values that would not go over 2 pi. Do y'all remember that? All right, so if I let n be 0 here, the first one's be pi over what? 8. Then if I let n be 1, that would be what? 9 pi over 8. Then if I let n be 2, it's going to go over 2 pi, isn't it? So those are my two answers on that side. I let n be 0, I get 7 pi over 8. I let n be 1, that gives me 15 pi over 8, and those are your 4 answers. Might want to make sure you jot that one down, because you probably see that one again. Are there any questions on those trig equations? Alright, let's review this for a minute. Graphing polar. Alright, we're looking at this polar graph, and we want to graph 3, 150. Remember, in polar, you have an r and a theta. So if I want to graph 3, 150, I will go to, start at my origin. There's 150. I go out to the third ring, 1, 2, 3. Y'all remember that? Let's say I have -1, 7 pi over 4. I find my angle first. 7 pi over 4 is right here. Okay, that's ring 1, but since it's negative, what quadrant would this be in? 2. So I go over to pi over 4, and it would be right there. Y'all remember how to do that? If this had been negative, you would have found it first and then apply that. Always find this first and then the ring. Is everybody good? Alright, let's look at this. Number 3, it says find the rectangular coordinates. What coordinates is this right now? Polar. Okay, polar has a r and a theta, but you want rectangular. You want an x and a y. What was the formula for finding the x? X equals, now using what we have here, x equals r times what? Which one's associated with x? Cosine or sine? Cosine of theta. You remember that? And then y is equal to r what? You're not going to have all these formulas. You've got to learn these formulas. Alright, so x equals, my r value is -3, cosine of 120. Y equals, are we not doing announcements?
They're messed up.
Oh. Y equals -3, sine of 120. Now, TJ, you're going to have to go back in probably a few days and watch all these videos at the beginning, because that's when we'll review for final, and you've been doing announcements, okay?
Yes, sir.
Cosine of 120. 120 is in quad what? 2, okay? And that's going to be a -1/2. Does everybody understand that? So x equals positive 3/2, because negative times negative. Y equals -3 times the square root of 3 over 2. That's going to give me -3 square root of 3 over 2. So your ordered pair would be 3/2 -3 square root of 3 over 2. We good on that? We'll stop there because I know you're getting overwhelmed. All right, we'll do this on Wednesday. Find the polar coordinates. Are we good on those? Alright, let's look at what we're going to do today, guys. What we're going to do is we're going to review the formal, you got to test tomorrow, formal definition and the derivative rules. So we're going to just review that for a while. So what I want to start off with right now is just reviewing the formal definition. Formal definition. You have 20 questions on your test tomorrow. 4 of them deals with formal definition, well, 6 deals with formal definition, and the other deals with the derivative rules. So here it says find f prime by using the formal definition. And we all by now should know the formal definition of a derivative. F prime is equal to The limit as h approaches 0 of f of x plus h minus f of x over h. Make sure you know that, okay? So here we go. If I find f of x plus h first, I get that right there. Okay, so now I'm going to do f prime of x equals the limit as h approaches 0 of square root of x plus h plus 2 minus f of x square root of x plus 2 all over h. I applied direct substitution. I plug 0 in there, I get undefined situation. So I'm going to have to use one of my toolkit strategies. Which one I'm going to use? Rationalizing the numerator. So I'm going to multiply and let's take our time doing our math here. Watch this. This times this would do what with the square roots? Cancel out. So I'm going to just put x plus h plus 2 in parentheses. Cancel the square root out. Now, we're all intelligent in here. If I say this times this, whatever that monster is, it's a positive, isn't it? If I say this times this. And I'll say this times this, whatever that monster is the same thing, but negative, isn't it? So what do those two things do? So do you have to worry about writing all that jumbo down? Okay, so don't let that get you confused. Now, a negative times a positive is what? Now what happens to those square roots? They do what? See, that looks a whole lot better, doesn't it? Alright, now, all over h times this, h times this. Now, the limit as h approaches 0, what's this minus going to do to everything in that second parentheses? At this time, everything that doesn't have an h should cancel out. Boom, 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 boom. Did it? Yes. Now, if you plugged in 0 right now, guys, would you still get 0 in the denominator? Because you got 0 times something, that's going to give you 0. So you got to do something else. How can you get that h on the top to cancel out? Do what in the bottom? Factor out of h. Very good. This cancels out. I'm left with the limit as h approaches 0 of 1 over . Now I'm going to plug 0 in. Plug 0 in, I get the square root, I get this right here. X square root of x plus 2 plus square root of x plus 2. Are those like terms, guys? How do you know those are like terms? That's correct. They have the same thing under the what? The radical, don't they? They have the same thing on the radical. So could you add what's on the outside? Yes. So that's going to give me 1. What's understood right here? 1. What's understood here? So this will be 2 square root of x plus 2. That's your derivative. That's your derivative right there. Do you understand that? Okay. Now, that is your derivative. That's f prime. Now, I want to know the slope of the tangent line at x equals 2. Don't forget to do this tomorrow. What's the slope? How do I find that? Take that and plug it into the what? Derivative. So there's your derivative. Now, I'm going to plug that in. Two plus 2 is 4. Square root of 4 is? So I get 1/4. So my slope of my tangent line there is 1/4. It's positive. What does that let you know about the graph? Because that's going to be a question tomorrow. It's increasing. If this had been negative, it's what? If it's 0, it's a what? Turning point. Do you understand? Okay. Let's look at another one. Now, guys, I'm not going to do this. I think we're all good on this. I'm just doing a fraction. But if I ask you this, you know how to do something like this, x squared plus x minus 1. Y'all get those. I'm doing the ones that has the radicals and the rationals. Are y'all good with that? Yes, buddy. But are y'all good on stuff simple like that if using the formal definition? Or do I need to do one like that? Okay. Okay. I won't do all of it, but I start. Are you good with that? Okay. Number 2. Alright, so f prime of x equals, if I plug x plus h in, I get 1 over x plus h plus 3 minus f of x, x plus 3, all over h. I should have put the limit as h approaches 0. Alright, so that's my start. Now, if I plug 0 in, I get 0 in the denominator. Can I have that? So I need to find a common what? In the top. Okay, common denominator in the top. Your common denominator would be both of them, wouldn't it? So what is this one missing? This is missing the, so I need to multiply the top by x plus 3. You said, Mr. S, do we have to do like what we're doing now? That's why I'm doing it right now. Alright. That right there is missing over here, so I'm going to multiply the top by that. Have to be very careful to remember that negative there. Yes, TJ? Did you have a question? Okay. All over h. The limit as h approaches 0, that's a negative 1 times r. That's going to be negative x minus h minus 3 all over at this point, everything that doesn't have an h should cancel out. Boom, 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 boom. It does. Now the limit as h approaches 0 of negative h over x plus h plus 3 times x plus 3. I'm going to go on and say times by 1h, because dividing by h is you got to multiply by the reciprocal. I didn't have to show that step. You can do that. What happens to these h's right here? So I'm left with the limit as h approaches 0 of negative 1 over x plus h plus 3 over x plus 3. Now, I'm going to try direct substitution. Plug 0 in for h. Get negative 1 over x plus 3 times x plus 3. I can rewrite that as negative 1 over x plus 3 squared. That is my derivative for that problem. I plugged 0 in for h and got x plus 3 times x plus 3. So that's my derivative. Now, I want to know what's going on. X equals negative 1. So f prime of negative 1 equals negative 1 over negative 1 plus 3 squared. That gives me negative 1 over 2 squared, which is negative 1/4. So I got negative 1/4. So what's happening in my graph right now? Decreasing. That's the slope of the tangent line at that point, that instance. That's your IROC. Are we good on that one? Okay. On this one, I will first find x plus h. That would be x plus h squared plus x plus h minus 1. I got to square 4 that out. So I FOIL that out as x squared plus 2hx plus h squared plus that. Okay, so that's what that is. So I'm going to go down here. Now, f prime of x equals the limit as h approaches 0 of x squared plus 2hx plus h squared plus x plus h minus 1 minus f of x all over h. The limit as h approaches 0. I'm sorry. X squared plus 2hx plus h squared plus x plus h minus 1 minus x squared. That changes all the signs. At this point, everything that doesn't have an h should cancel out. Two hx plus h squared plus h. Now, I'm not going any further, but you know you will factor out an h commonly and then cancel that out. Does that make sense? Just be careful with your algebra up there. Are there any questions on formal definition? Now we're just going to use the shortcut ways. Before we go over page 29, I have some up here that I want us to discuss on our own. Okay? So we're just finding f prime of x. We're finding derivative of all this. Alright, so on number 1, if I'm finding f prime, what would be the first thing you would do here, Greg? I would rewrite it with fractions, okay? I'm going to rewrite it as 1/4 x to the 4th plus 1/3 x cubed plus 2x. If you have fractions, if you have radicals in the denominator, if you have negative exponents, you got to rewrite it, okay? Now, I say f prime, 4 times 1/4 is what? 4 times 1/4 is 1. 4 minus 1 is 3 times 1/3 is 3 times 1/3. 1, thank you. Take 1 off that, that's going to be x squared. 1 times 2 is what? And then 1 minus 1 is, so there's your derivative. You see that? Number 2. And remember, guys, when you got plus in there, you're going to take the derivative of each individual one, okay? So on this one right here, I'm going to take the derivative of this one, then take the derivative of that one. So I have f prime of x. 4 times 1 is? 4 minus 1 is? When you involve trig, if there's a trig term in this, you just take the derivative of trig. So what is the derivative of cosine? Negative sine. What is derivative of sine? Cosine. Don't forget that cosine is negative sine. Okay, so cosine is negative sine, so you have minus 1/2 times negative sine. What's a negative times a negative? And that would be your derivative. Are there any questions on those two? Alright, number 3. We got a lot going on here. You need to rewrite it. First off, the reason I'm rewriting, there's a radical. You need to write it as an exponent. And then you see this, something denominator. You got to rewrite that, okay? That's got to get your attention. So let's rewrite this. And we rewrite it because you've got to have some type of exponent in order to do the derivative. So 1 plus, how can I rewrite this on TJ? X to the what? Thank you. Plus, Grace, how can I rewrite this one? X to the what? Positive or negative 1/2? Negative 1/2. Very good. Now that I have some type of exponent to work with, I can find the derivative. Is that Roger? What's the derivative of 1?
1.
Derivative of any constant is equal to what? 0. Derivative of any constant number is 0, so I don't have to worry about that. Now, bring this down. 1/3 times 1 is 1/3. 1/3 minus 1 is negative 2/3. Negative 1/2 times 1 is going to be minus 1/2. Minus 1 would be what? Negative 3/2. Now, those are your derivatives. Now, in the end, we're going to rewrite it without the negative exponents. Okay, what's my root here? Is it a cube root or square root here? Cube root, and what goes with the exponent? Do you understand how I wrote that? Okay. Minus. It's going to be a square root, and a cube is going to be under there. Do y'all understand how I wrote the final answer? I had to rewrite it, find the derivative, and then write it back in another way without those. Number 4. What's the only thing that should be catching your eye right now that's a trouble area? You need to rewrite that, don't you? Okay. So f of x equals x to the 6th minus x to the 4th minus x to the what? Negative 5. It just changes the sign. It's negative here, changes that. Now, we're ready to find f prime. 6 times 1 is x to the what? 4 times negative 1 is x to the negative 5 times negative 1 is positive 5, x to the what? Okay, now write the final answer. You see I wrote that final answer there. These are so much quicker than a long definition. Number 5. What's the only thing that catches your eye that you need to rewrite right here? Is the 1/2 okay? Yes, that's a constant. So what's the derivative of this? I don't have to worry about that, do I? Alright, so f of x equals 1/5 x to the what? Negative 1/2. So f prime would be negative 1/2 times 1/5 would be what? Negative 1/10. X to the negative what? And then that's just 0, isn't it? So now I'm going to write my final answer. F prime of x equals negative 1. That is the square root of x to the cubed. And that would be my derivative for that particular problem. Are we good on that? Alright, number 1. I want Big T to present 1 and 2. Go on page 29. Page 29. You got this note. Go ahead, teach class 1 and 2. Everybody's presenting something today.
Well, yeah, the first one will be 0.
Why is it 0?
Because it equals 3, and there's no...
3 is a what? What type of numbers? I just stated about 5 times. What type of number is 3? It starts with a C.
Constant.
Good. Okay.
What?
Number 2. Go on to number 2.
Would it... And number 2 would just be 2x?
Why? I know.
Because 4 is a constant, and x you multiply that because of the 1, and multiply it by 2, and that's 2x.
Good job. Next time that put y prime equals 0. G prime of x equals 2x. Okay?
Okay.
Thank you. Number 3, is that Rogers? 3 and 4.
I have a second and a pencil.
You can go up there and do them while you're up there. For 3 and 4, let's go. Remember what I taught you about outside that door?
Yes, sir.
Strike 2.
Oh, Lord.
And you strike out.
Okay. So 5's a constant, so you don't have to worry about that. And then that'll be 1.
Very good. Why is it 1?
Because when you do the power thing.
Bring the 1 down, times it by 1, don't you?
Yep.
1 times 1 is 1, and then the exponent is 1 minus 1 is 0, so you don't have to worry about x to the 0. No, very good. Number 4.
Okay. So this would be 3t squared minus 2. Yeah, that's it.
Now explain why that's correct.
Okay, and then it's the same like power rule. So 3 times 1 is 3, then you minus 1, and it's 2. So it'd be 3t squared, and then it'd be minus 2 because there's no power higher than 2.
Very good. That's another one right now. That moon, 5 to 6.
He's trying to do it.
I know. That's all I'm saying, working hard over it.
Alright, so number 5. So we'd multiply the 2, so it'd be 2, or then you minus 1.
Sorry.
Okay.
Don't be nervous. Be nervous.
Alright,
Been a family all year. Let's go.
so it'd be 2x. Then,
Why is it 2x?
So 2 times 1, and then 2 minus 1 to the first power, so 2x minus, then 3 times negative 1/2 is negative 3/2, then 3 minus 1 is 2, so x squared.
Very good, but next time put F prime of x equals that, okay?
Yes, sir.
Number 6.
Number 6, 2 times negative 2 is negative 4x to the first power.
Scoot it over just a little bit. Oh.
My bad. Then 1 times 3 is 3, and be x to the 0, and the -6 is a constant, so it'd be 0.
All right, number 7. Brendan, number 7, 8.
I got 8 and 9 because I had questions.
Okay. Number 7, Taylor, do 7 for us, huh? You got this, Taylor. Now, at any point you don't understand one of these, say, Miss Fisher, can you go over that one again? Do that, it's fine. Okay, you put it down on number 7.
Oh,
Here you go.
okay. So I did -1 times 1 in front of x, and I got -1x. And I subtracted 1 to the -2, and then 3/2 times a -3.
That's correct.
Is it? Okay.
Right, no, negative 3
No.
halves times 3,
That'd be -9/2.
negative 9 halves. Just fix it right there. Use one of those.
Okay.
Negative 9 halves. There you go.
Okay, x, and then subtract 1. That's 1/2.
Wait, is it 3 halves or negative 9 halves?
-9/2.
Back to fix it again. Or is that 9 or?
Yeah, that is a 9. Sorry.
Okay.
And then 3/2 minus 1 is 1/2. So x to the 1/2, and then plus 20 over 7 because you multiplied 4 sevenths by 5, and then you subtract 1 to get x to -3/7.
Yeah, does everyone understand how she got negative 3/7 there? 4 sevenths minus 1. Put that in the calculator to make negative 3/7. Do we understand that? Okay. Yes. Because 3/2 minus 1 is, yeah, you see what I'm saying? Okay, now, yes, keep going.
And then I just
Cleaned it up a
simplified,
little bit.
So -1 over x squared, and then -9/2 square root of x, because 1/2 means square root. And then I put the x in the denominator, but then made it a radical.
You understand how she put that third term, 20 over 7, the 7th root of x to 3. You have stuff like that tomorrow. Do you understand that's written correctly? Is everybody good on that one? Okay, Brendan, come on, do 8 and 9, buddy.
So x squared would be 2x because you bring the 2 down and multiply it by 1, and then 2 minus 1 is 0, or 1. So you get 2x, and then you do negative 1/2 times positive 1/2 to get negative 1/4, and then x would be square root x.
Okay, let's stop at that for a minute. You're going to say 1/2 minus 1, aren't you? Would that be positive 1/2 or negative 1/2?
Negative.
Negative 1/2. So fix that right there. Be minus 1/4 x to the negative 1/4. You can just
Wait, does the negative in front of the x or the 1/4 not take care of
let me
that?
fix it for you. Stand right here, buddy. Let me show you. So what I would do here, 1/2 times negative 1/2 is negative 1/4. That's to be x to the negative 1/2. So then that would equal 2x minus 1/4, and the square root of x will be in the denominator. You see that, bud?
Yes,
So. Okay. Does everybody understand that? Are we good? Continue.
So on number 9, 5 is a constant, so you don't have to worry about that. And then 2/3 times 1 is 2/3, and then you minus 1, which is negative
Negative what? That's right.
1/3. And so you move it to the denominator, and it'd be the third root of x.
Very good. Leave that right there for just a minute. 2/3 minus 1 is negative 1/3. X to negative 1/3, you put it in the denominator, okay? I also like how he uses, you can either use y prime or he used that notation dy over dx. That also means derivative. Very good on use of that. Good job. All right. Number 10, Miss Wells.
Alright, so you take the negative 1 in front of x and put it in front, so it'd be negative 1, and then when you subtract 1, it'd be negative 2.
Good job on that.
And then you multiply 2 by negative 3, which would be negative 6x. And
Very
then
good. Now at this point, right here, this is let's talk about how we're going to rewrite this. So,
I swapped the x.
Yeah, so it's going to be negative 1 over x squared minus 6x. That will be your final. You can't combine those, huh? You see that?
Yeah, I see what I did.
Does everybody understand that? Are we good? All right. Thank you, hon. All right. Caitlin, do the next one for us, huh?
Number 11, right?
Yes.
So on this one, I took the negative 3 and I multiplied it by 3, which gets negative 9, and then x, and then subtract a 1 from negative 3, which is negative 4. Then I took the x to the 4th into the denominator, and it's negative 9 over x to the 4th.
Very good. Good job. Okay, number 12. We're just going to talk about this one. What do you think you need to do first on that one? Product rule or quotient rule? On number 12. What's 3 minus 2? So you got y equals x, don't you? What's the derivative of y equals x? Right, 5, 4, 1. Thank you. That's it. 1 is your answer on 12. Y prime equals 1. That's all you have to do. All right. Number 13. Jake? Some of y'all thinking, oh, Mr. It's not going to get it. I got a whole other sheet of the other one sitting at the desk. They're going to present. Y'all else going to get cheat sheet.
Oh, I knew you were. That's why I was trying to
There? Okay, so you multiply 3 times the 1, which is in front, and you get 3. And then you subtract 3 minus 1 and you get 2, so it's 3x squared. And then for the 3 right here, or the negative 3, I guess, you multiply it times the 1 and it's just negative 3, and then you subtract 1 minus 1 and it's 0, so there's no x. And then for this one, you multiply the negative 4 times the 2, or times the negative 2, and it makes a positive 8. And then you subtract 1 and it's negative 5, and then you just put that in the denominator.
Good job. Good job. Good job. Okay, number 14, just recall the answer side is g prime equals 2x minus 2. That's an easy one. I don't know why they got to do some parentheses there, but that's it. Number 15. What do you think we need to do? Let's just talk about this for a minute. What do you think we need to do first on number 15? Distribute. So let's distribute that. That's L of x equals 6x to the 4th plus 15x cubed. So 6x to the 4th plus 15x cubed. Then find the derivative. F prime of x equals 4 times 6 is 24, minus 1 is x cubed. 3 times 15 is 45, x squared. Are we good on that one? Okay, Jessica, do number 16, please. While she's doing number 16, let's go on number 17. What's the answer for 17? 8x plus 3. That's an easy one.
Right. 9/4 multiplied by 1 is 9/4 x, and then you subtract 9/4 minus 1, and it's the 5.
Correct. Now, how could you write that as a radical? 9/4, the 4th root of x to the what?
5th.
Yeah, that's good. Thank you. Good job. All right, number 18, Josiah.
Hey, are we supposed to write that one on the radicals?
You can leave it like that. I'll give you that.
What, both ways?
Both ways. But I prefer you write it as a final as a radical. Right?
I did 4 times 5 and I got 20. Then I did 5 minus 1, I got 4. I did 4 times negative 7, I got negative 28. And then I subtracted 1 from the 4 and I got 3. I did 9 times 3, or negative 9 times 3, I got negative 27. I had 3 minus 1, I got 2.
Very good, very good. Number 19, Conley. Bring it up just a little bit. There.
Okay. So multiplied 6 times 8 and got 48, and then subtracted the exponent by 1, so it's 48x to the 5th. And then 5 times 5 is 25, and then subtract the exponent by 1, so it's 25x to the 4th. And then 3 times 9 is 27. Subtract the exponent by 1, so it's 27x squared.
There you go. Very good. All right. You had another page due on Friday as well. It was page 29. What was the other page? Let's see here. 27. Okay, let's turn that page. Catherine, number 1. Okay, you can look at that. Y equals 5. What's the derivative? 0. Thank you. Do you want to come up here and explain that one? Or are you good? Okay. Sean, how about number 2? 90x to the 17th. Very good. All right. Number 3. Max, come on up here and explain 3 for us.
Uh, 5 times 4 is 20. 5 minus 1 is 4. X is a variable, so it's just 1.
Very good. Very good. Number 4, TJ.
Okay, 4 times 4 is 16. 4 minus 1 is 3. And then 5 times 1, or negative 5 times 1 is negative 5. And then x will be to 0, that's 1. And then negative 3 is a constant.
Why are you being so quiet?
So quiet.
Yeah, so robotic and quiet. All right, good job. Number 4, Jessica. We're over here, Jessica. And Miss Barlow, you can go and get up there for number 5, period. Oh, you're doing number 5, Miss Sherman. Number 6, Miss Barlow.
Okay. Okay, so I just multiplied 5 over 4 times 3 to get 15 over 4, and subtracted 1 to get 1/4, and then I just put it as a radical, the 4th square root of it.
That's exactly how I would like it. Thank you. Is that? That's on the side of you. You have it on the side or in the numerator. All right, go ahead.
Number 6, right?
Yep.
Alright, so I just multiplied 5/4 by 2/3 and got 5/6, and then you subtract 1 from 2/3, which gives you negative 1/3, and so you rewrite it as 3, square root of 3.
In the denominator. Very good. See, it's clearly in the denominator. That one is perfect the way it's written right there. Very good. Number 7. Reese.
So you multiply negative 4 and negative 5, and that gives you a positive 20. And then you subtract 1 from negative 5, and that'll give you negative 6. So it gives you 20x to the negative 6, and you put that would be negative 6 in the denominator.
Very good, in the denominator. Number 8, Ms. Dosser.
Okay, I rewrote it to 3x to the negative 3rd, and then I multiplied 3 times negative 3, which is negative 9, and negative 3 minus 1 is negative 4, and then
I put -4 in the denominator, so I got -9 over x to the 4th.
Very good. Does everyone understand why she had to rewrite it to begin with? There was a variable in the denominator, and in order to take the derivative of something, you have to have an exponent. That's why she rewrote it like that. Very good. Number 9 and 10, Noah.
Alright, so on 9, I did 2/3 times 1 equals 2/3, and then 2/3 minus 1 is x to the negative 1/3. So then I wrote, I messed it up right there, so then I wrote 2/3.
Yes, 3 goes in.
Yeah, okay.
Yeah, does everybody understand that middle step? You don't worry about that middle.
Yeah, I
That
messed that
final.
up.
That's good. Okay. Make sure you put y prime equals, okay?
Okay.
Number 10.
And then on this one I rewrote it, so -2 times x to the 1/4. So 1/4 times -2 is -1/2, and then 1/4 minus 1 equals x to the -3/4. So I wrote -1 over 2, and then the 4th root of x cubed.
Good job. Good job. Great, number 11. Or Grace, which one do you want to present, 11 or 12? You made the final decision. Oh, okay. So, Gray, you go do number 11 right now while Gracie does 12.
You gotta write it down.
You can do it right up there.
Wait, so 4 times 2/3
Well, you can do
is
that in your head, smart as you are. You don't need to calculate.
Oh, I
4 times
can.
2/3.
X to the 3rd, and then this would be plus 5, right? And then wouldn't I have to rewrite it first?
You don't have to. You don't really need to rewrite it there because you already got an exponent up there, don't you?
Okay, yeah.
So -3 times -1 is. Does everybody understand? -3 times -1 is that positive 3. Okay, good. Now write your final answer. Yeah, on that x of -30, it's tempted that you set -3. You want to write it in the denominator there, but that's not going to do you any good right there. Okay. Very good. That is your final answer. That's the derivative of that. Very good. Number 12, Grayson. Your homework. Now don't start packing up yet, but your homework is study for your test. You have no written homework. Study for your derivative test and start studying for a final. That's your homework every day this week. No written homework, but study. Okay.
So 4 times the negative.
Hold up. I shouldn't be hearing zippers or anything on the book bag. Stop what you're doing at the moment. Thank you. Continue.
4 times the -1/2 is -2, and then the 4 minus 1 is 3, and then you do the 5/3 times 3 is 5, and then x, or 5/3 minus 1 is 2/3, and then 1 times 2 is 2.
Very good. This is all correct. You see this here? Don't even miss here. You forgot to burn that 3 down.
Oh.
You see that?
Yeah.
Does everybody understand that? Is anybody lost on that one? Okay. Are we good on this one? You understand what your assignment is? Study, study, study. Thank you, Mike. No, just derivative.